All right, so today we are going to get started with the meat of Chapter 4. In Chapter 4, Day 6 notes, we're really going to focus on congruent triangles today, and then we're going to talk a little bit about isosceles triangles. So congruent triangles is a huge study in geometry. We're just going to kind of do an overview of it, and we're going to talk about corresponding parts, and then we'll follow up this video with a live lesson on triangle congruent proof. So there's definitely more to come, and this isn't meant to be a complete explanation. Just to get started here, remember you can follow along in your Day 6 notes packet, which has all of the blank slides in it for you. Let's talk about congruent triangles. So we've talked about congruent lines before, or congruent angles, and having them be, where this angle right here is congruent to this angle right here because they each have an angle mark. And this line segment has this line segment. So, for two triangles to be completely congruent, we need to say that they are the exact same size and the exact same shape. So they are said to be congruent. So even though they have the same shape and size, they may be proportioned differently. So let's talk about proportions for a second. We can have this triangle right here that I'm drawing in red, and that may have the exact same proportions as the two triangles here, meaning their angles are congruent. So let me try to draw that in for you. So if their angles are congruent, but their sizes are different, they're considered to be similar. And the little tilde symbol that I just drew is your sign for similar. So the fact that the angles are the same is going to show us similarity. Then the fact that the sides are all congruent and the side measures are equal, that's where our congruency symbol comes from. All right, so here you can see that every line segment matches up with every other line segment on our triangle, and we call these corresponding parts. So this line segment corresponds to this line segment. This line segment with the 3 dashes, the long one, corresponds with this one, which is the long one. And same with the angles. This angle corresponds to this angle, and this angle up here corresponds to this angle down here, and our bottom right corresponds to the bottom right. So again, corresponding is going to mean the parts that are the same, and we need all 6 of these things to be true in order to say that our triangles are congruent. So let's talk about corresponding parts of two congruent triangles that are congruent. So that's a mouthful, right? What corresponding parts of the two congruent triangles are congruent? So let's take a look here. We have in green line segment AB, and we have line segment ZY. They are going to be considered congruent, so we're going to put a dash there. First of all, we know that these two triangles are congruent. Okay, so we have two congruent triangles. So just wanted to highlight that. So AB, we would say, is congruent to ZY. We can pick another part. Another part of this triangle might be angle B. So angle B is going to be congruent to angle Y. Because they're congruent, we're going to be able to list them. Angle B is congruent to angle Y. They are corresponding parts. Let's look at another part. Another part I have is line segment BC. Line segment BC is going to be congruent to line segment YX. So we're going to put 2 dashes on both of those lines to show that they correspond to each other and that they are congruent. And then we can write that out. BC YX. I also want to draw your attention to how I'm writing these. Notice for AB, I went from top to bottom. So for ZY, I also went from top to bottom. And it doesn't matter which one you choose for the first one, but whichever one you write first, you should follow in the next one. So for BC, I went from left to right. So when I wrote YX, I didn't write XY, I wrote YX because I went from left to right. Another corresponding part are angle A and angle Z. They're both in the upper left-hand corner. So I have angle A is congruent to angle Z. Another corresponding part might be angle C and angle X. So they each have 3 dashes. And so we can write that out. Angle C is congruent to angle X. And there should be one more corresponding part, and that is going to be here in blue, my line segment AC. So I'm going to put 3 dashes through that one. And line segment ZX also gets the 3 line segment treatment. And now when we write it out, whichever one I pick for my left-hand side, so I pick AC, which went from the upper left to bottom right. I then had to go upper left to bottom right for ZX. So the order there does matter. So again, I could have written CA, and that would have been fine. But if I wrote CA, I would have needed to write XZ. So I just want to put a little or there for you, so you know either works, but the order that you go on the one side needs to go on the other. So there are 6 sets of corresponding parts for our triangles when they are congruent. And those 6 things are what we're going to look for when we start writing our proofs. And once we say that, once we show that all 6 of those parts are congruent, we can say that triangle ABC is congruent to triangle ZYX. That is what we call our congruency statement. All right, that is a congruency statement. And that's what we're going to be like. That's our end goal for our proof. So what a proof is kind of saying is we need to show you that these are congruent. So I'm going to show you how all of their parts are congruent, and therefore the triangles themselves must be congruent. And we are going to use that using this concept of CPCTC, which we'll talk about a little bit in the next slide, but it basically has to do with this: corresponding parts of congruent triangles are congruent. CPCTC. Okay, so this slide demonstrates the concept of CPCTC, which again just says that the corresponding parts of those congruent triangles are also congruent. And that's it. That's all that statement kind of says. And that's going to be our goal. So what's going to happen in a lot of the proofs that we're going to do is you're going to be given like 3 or 4 of these congruency statements, and we're going to have to use what we already know about math and geometry to find the other 2. And then once we can prove that we know all 6 things, 3 sets of sides and 3 sets of angles, then we can prove our triangles are congruent using CPCTC. So we could use our exterior angle theorem. We could use our triangle angle sum theorem. We can use reflexive and symmetric properties, vertical angles, alternate interior angles, linear pairs. We can use a ton of things that we've learned so far this year. Another item that you might want in using these proofs is our third angle theorem. So this third angle theorem says that if 2 angles of one triangle are congruent to 2 angles of another triangle, then the third angle must also be congruent. So let's show that to you here. So pretend we have this situation. I have an angle 31, 87, 62, and I have a second triangle that has 87 and 62 as its angles. Well, that tells me that the third angle has to be 31, and the proof for that is basically just our triangle angle sum theorem, right? If I didn't know that this was 31, I would have to subtract 87 and 62 from 180 and I'd get 31. So if I'm over here and I only have 87 and 62, we can find that and solve for 31. But this comes in handy when we're not given actual angle measures, we're just given their marking. So maybe we have angle 1 and an angle 2, angle 1 and an angle 2. So this is what we're given, and we want to know what the third angle is. Well, this one has to then be congruent to this one, and that's what your third angle theorem tells you. All right, we'll definitely be playing around with these a lot, but I want to switch gears and talk about isosceles triangles a little bit. So isosceles triangles, there's a conjecture about them that says isosceles triangles has 2 congruent angles. It is just a conjecture, just because it can't be proven mathematically, but that's a whole nother conversation, but it hasn't been disproven. So we're gonna take it for fact here. So we have our isosceles triangle conjecture has two congruent angles. That is called your vertex angle, is going to be the one that is not congruent. And then the opposite sides are the legs. So our vertex angle, and then opposite of each of our angles that are congruent are our legs. Okay, and these are often called your base angles. And then again, these are your legs. Okay. Converse of the isosceles triangle conjecture is that if you have two angles that are congruent, well then, again, we have our vertex angle, then those two sides must be congruent. So it works both ways. If you see two congruent sides, you're going to know that those base angles are congruent, or if you have two congruent angles, you're going to know that the two sides are congruent. And if it has two congruent sides, it is isosceles. So again, our vertex angle is the angle between the two congruent sides. Legs are the congruent sides. Then we have our base side, so you have a leg, and a base. And so then we have base angles. And it is really important that when we discuss isosceles triangles that we know that language and we use that vocabulary when referring to the different angles. So using just the idea of what an isosceles triangle is, that if you see two congruent sides, we can assume two congruent bases, or if you see two congruent bases, you can assume two congruent sides. There are so many different kind of triangle problems and triangle angle charts that you can fill in, like the ones we had done on the last assessment. So we're going to do some flowchart proofs together. I'll show you what those are going to look like. We're going to do some flowchart proofs together. So these are going to be literal like flow charts that we fill in. So there's 4 of those. We'll do 2 together, and then you'll do 2 for homework. And then your practice worksheet has you filling in all sorts of angle diagrams and solving different problems using isosceles triangles and equilateral triangles as well, because we know that on an equilateral triangle, boom, 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 these angles are always 60 degrees. So if you don't have that one kind of figured out by now, you might want to write that one down, that the equilateral triangles are always 60 degrees. So let's talk about flowchart proofs, and then we'll solve some problems with isosceles.